All right, we're going to go ahead and do corrections on the assignment of word problems. So they asked for number 12 first, and I did think 12 was one of the harder ones. All right, we need to find the dimensions of a rectangle whose perimeter is 42 and the area is 104. And that's all they gave you for that. So the first thing you need to know is your perimeter formula. So if you've got a rectangle, remember perimeter is 2L plus 2W, right? Area is length times width. So they gave us the value for perimeter to be 42. So if we put a 42 here, this is an equation that we have. But how many different variables do we have? Because they didn't compare the length and width in the problem. So we couldn't write one in terms of the other. So we have two variables. So area they give us to be 104. We have two variables there as well. You guys, when you have two equations with two variables, what is it you have? Yeah, we got a system of equations here. So we need to get one of these to get the variable alone, an L or a W, and it really doesn't matter. I think this one might be a little bit easier to get one of them alone because over here you're going to end up with a fraction because you'd be dividing. So you guys, this goes back to literal equations. Remember the literal equations, moving things around? So let's say we get the L alone. What would the first thing be to do to get the L alone? Yep, minus 2W. Notice how everybody's even here. This is going to be good. You have 42 minus 2W, but you still have a 2 with your L. So what would our next step be? So what I would recommend you do, since everyone is evenly divisible by 2, do each one individually. All right, what do we have now? Well done. Substitution method. We have a variable alone. We have a second equation we haven't used yet. L is the same as 21 minus W. We can go ahead and take that and plug it in right there. So I'm going to put the W first. Commutative property says I can switch that around. I like my parentheses to come afterwards. So if we kind of clean that up, we have 21W and then minus W squared. Agree with that? But when we're solving, what do we have to set it equal to? 0. Remember, we'll use a zero product property. I don't like the squared term to be negative, though, so instead of just moving the 104 over to get it equal to 0, I'm just going to move everybody else over, and then W squared will be positive. So we'll add the W squared, and what do we do with the 21W? Yep. Remember, when they're on the other side, they will be opposite signs. So what are we going to have over here with the 104? Yep, positive W squared, the minus 21W. Put your constant 104 last. And now it is set equal to 0. We don't have a number in front here to worry about. We do need to break down a 104 to try to get a 21. So, if we want to break down a 104, we want to try to get a 21, what do you think will work?
-15 and -8.
Oh, you guys are quick. Excellent. So 8 times 13, and who did you say was the negative? Ah, because we need them to add to be a negative 21. Concur? Okay. What goes inside parentheses?
W minus 8 and W minus 8.
So zero product property states you've got two factors being multiplied to get a 0. One of those Must be a 0, so you take each set. What would W be here? Okay. It could be an 8, or W could be a 13. So if W is an 8, you can plug it in to either of your two original equations to see what the L would be. So if we use this as our width, the width would be 8. What would the length be? 13. But if the width is 13, so either way we kind of get the same answer. So it's an 8 by 13.
And it wouldn't matter if we solved for L, right?
Correct. You could have gotten the L alone over here. You would have had the same result. You just would have found what the L was. All right, 18 is going to be the next one we go over. So that one deals with choosing one of these two formulas. So if 18 is talking about a rocket fired upward with initial speed of 1,960 meters per second, how many minutes does it hit the ground? All right, meters per second, which of these formulas will we use?
The one with 49.
Yes, the 4.9 because h is in meters. This is going to be our rate. How many minutes means time is missing. However, this is meters per second, correct? When we find the answer for time, it's going to be in seconds. And then they are asking how many minutes is that, so let's not forget to do that one little step at the end. But let's find our time first in seconds. So we're choosing this formula. The rate is 1,960. It says how many minutes does it hit the ground? Notice they didn't give us a height. When you hit the ground, that's what they want. What's your height? Yeah, that's their creative way of giving you that height is 0. So we'll put a 0 here. Good, it's already set equal to 0. Rate 1,960, time is missing. Shall we swap sides to get that t squared to be positive? Just bring everybody over. So if all of these guys are brought over to the other side, that just changes their signs. So what would they be if they were over here using inverse operations?
4.9 t squared minus
Yeah,
1,000.
that would be a minus over here. So we've got it set equal to 0. That's what we want. And then what was my suggestion? Remember yesterday? Yeah, pull that 4.9 out. But look, something else can come out with it this time. Yeah, they also both have a t. Because we don't have that third term, with height being a 0, we just have these two terms, and they both have a t. So let's not only pull the 4.9 out, let's factor the t out with it. Calculator's handy. This will just leave us with what?
400. Oh, nothing.
The first guy. I like that one for the second one.
T.
T. And then you said 400 here when you divide?
Yep.
Okay. Don't forget your equal 0. Now both of them have a variable. Here's your first factor, here's your second. They both have a variable, so this time we need to take both of those into account. The 4.9t can be your 0, so what would t be then?
0.
So, at 0 seconds, meaning you haven't even thrown the ball yet, the height is 0. Well, that makes sense. You're still holding it. It's not up in the air yet.
That makes sense.
Okay? But here, we have t minus 400 could be our 0. What would t be now?
400.
Yep, add 400. And remember, this is in seconds. So 400 seconds later, it's 0 again. That means it's hit the ground or someone caught it. Okay, it's no longer in the air. So technically we have our answer, but they did ask for it in minutes.
So our answer
Well, they want to know how many minutes, so we just have to, yeah, the answer is 400 seconds, but in minutes, what would we have to do with that 400?
Put it over 60.
Yeah. If you cancel out your zeros, what does 40 over 6 reduce to?
40,
20 over 3.
And how many times does 3 go into 20? That gets you 18, with how many left over? Yep, so 6 2/3 would be our minutes. All right, the next one we're going to go over is problem 15. So originally the dimensions of a rectangle were 20 by 23. When both dimensions are decreased by the same amount, do we know how much they're decreased by?
No.
What can we use to represent how much it's increased by, decreased by?
X.
Okay, that's going to be our variable. They're both decreased by the same amount. When that happens, the area of the rectangle then is decreased by 120 centimeters squared. Find the dimensions of the new rectangle. So pay attention to what they're asking for. So if we sketch out what's going on, here's our original rectangle. They give us those dimensions to be 20 by 23. Both length and width are decreased by the same amount, but we decided we'll use x to represent how much it's decreased by. So instead of 23 here, what is the new length?
23
Yeah, minus whatever that value is. Now the 20 is decreased by the same amount, so how would you represent that? All right. When this happens, the large area gets decreased by how much? What did it say here? So when this happens, that rectangle's area gets decreased by 120. Oh, there it is. Ready? Right? So the original rectangle gets decreased by 120 to become our small rectangle. We can kind of use that to help set up our equation. What is the area of the large? You're going to do 20 by 23, right? What is that?
460.
Thank you. It gets decreased by 120, correct? And that's the area of our new one, which is our smaller one. But how would you represent the area for that one?
23 minus X.
Oh? Oh, yeah. You're good.
Minus 20.
Yep. Does that make sense for the original? This guy minus 120 equals that guy. If we subtract 120 here, 340. And foiling. Foil, foil.
You get 460.
And then your minus 20x. And then plus x squared. All right, so what we did here is we combined our like terms, we brought our negative 340 over, and this is what we got. They decided they wanted the equal 0 to be on the other side, and we just rearranged our terms. All right, we need to break down the 120 to get a negative 43. Isaiah?
Negative 40 and negative 3.
Negative 40 and a negative 3. Will that multiply to be a positive 120? Okay. And they add to be a negative 43. Thank you. So our product is 0, so one of your factors must be 0. So either x minus 40 is our 0, or x minus 3 is our 0. What's the possibility for x here? Yeah, add 40 to each side, and here add 3, and you get a
3.
Now, one of those, if you take a look, remember what x represents. If you plug it in here and x is 40, what would 23 minus 40 be? or 20 minus 40. Can we have negative length and width values? So in this case, that 40 will get thrown out, even though it's a legitimate value for that equation. And that means x is a 3, but remember they're asking, what is the dimensions of the new rectangle? You've got to plug it in here. So you're going to take 23 minus 3 and 20 minus 3 to get your values. All right, 21, and then we're going to go ahead and start our notes. A signal flare is fired upward. There's your speed. Someone in a hot air balloon is at a height of 1,960 meters in the air. He sees it pass by. How long after this will the flare pass him again on the way down? That is what they're asking. So we need to find out first at what time it hits the 1960 the first time and how many seconds it hits it the second time on the way down. It's in meters. So we're going to use the 4.9 formula. Okay, we're going up, we're coming down. Here we are at 1960 feet. We want to know when it's going to hit that again because we don't want to know how much later it's going to be when it is at this level again.
What was the answer to number 3?
Number 3 is 6. I hope you like that answer. All right, our height is 1,960. The rate is 245 meters per second. Time is what we are looking for. We need to set it equal to 0, right? But because this is negative, I think we'll move everybody over. If you move everybody over, all the signs will change on the other side. That will now be a negative. So over here, I'll put the t squared first. It is now positive. I'll put the t next. It will now be negative. Keep the 1960 as is. And we are now set equal to 0. Well, what do I always recommend doing? Factor out. Say it again? Yeah, and in this case it will be, let's do the 4.9. We can't factor t out this time because now we do have a constant that does not have a variable. Calculator needed.
T to the second minus 50t plus 400.
50t. Not bad. These aren't bad numbers. It's the 400 we have to break down. But they need to add to be a negative 50. Ooh, I think I got it.
10, 9, 10, 40.
A 10 and a 40. And if they're both negative, when I multiply, I get my positive 400, and they add to be a negative 50. Now, the 4.9 does not affect us anymore, but he does still need to be there. This will be a t minus 10 and a t minus 40. These are the only two factors you need to concern yourself with because they are the ones that have variables. So your t minus 10 is your 0, or your t minus 40 is your 0. What is the first time we're going to get?
10.
Okay, so the balloonist is going to see it at 10 seconds after it goes up in the air. The balloonist is then going to see it at what time? 40 seconds. So this is at 40 seconds, but be careful, it's not 40 seconds after he sees it the first time. It's 40 seconds from when it's first shot into the air. So 10 seconds, 40, and they're asking how much longer after he first sees it will he then see it again? So after 10 seconds, how many seconds go by to get here? 30 seconds, and that's why the answer is 30 seconds.